In this video, I'm going to show you how you can know if a compound will form a precipitate. How to know if a compound will form a precipitate. A precipitate is simply a solid suspension in a solution. A solid suspension, like in these test tubes here, the solid suspension inside there is what we call a precipitate. But how can we know that a precipitate will form before conducting a reaction? So we can know if the precipitate will be formed by comparing the QC with the KSP. So if the QC is less than KSP, then no precipitate will be formed. And if the QC is greater than the KSP, then a precipitate will be formed. But what is this QC and what is the KSP? So QC is simply the quotient constant and KSP is the solubility product constant. The QC is calculated using initial concentrations of the products, but the KSP is calculated using the concentrations at equilibrium. So for example, if you have A reacting with B to form C and D, then the QC will be just the concentration of C raised to the stoichiometric coefficient N multiplied by the concentration of D raised to the stoichiometric coefficient M. That will be our QC. So you remember we use initial concentrations, not concentrations at equilibrium. So for example, we have this problem here which is saying a solution is prepared by adding a 700 ml of 4 by 10 to the power negative 3 molar of cerium nitrate to 300 ml of 2 by 10 to the power negative 2 molar of potassium iodate. Will cerium iodate, which is the resulting product, with KSP 1.9 by 10 to the power negative 10, form a precipitate from this solution? Will this cerium iodate as a product form a precipitate when we react cerium nitrate with potassium iodate? That's the question. So to know if cerium iodate will form a precipitate, we first need to know the concentrations of these two and calculate the QC and compare that QC to the KSP here. So if the QC will be less than KSP, then no precipitate will be formed. But if the QC is greater than the KSP, then the precipitate will be formed. So to find the concentrations of this product, we first need to calculate the number of moles of cerium and then the number of moles of iodate. From there, we're going to use that number of moles to find the concentrations when these two now are added. Okay, so to find the number of moles, we're going to use this formula there, which is number of moles is equals to concentration multiplied by volume. So the number of moles is given by concentration multiplied by volume. We have cerium nitrate here, so we want to find the number of moles of cerium. So we are going to multiply the concentration, which is 4 by 10 to the power 3 molar of cerium nitrate, by 750 ml to find the number of moles of cerium. Then that number of moles of cerium, we are going to use it to find the concentration of cerium when this 750 ml is added to this 350 ml of potassium iodate. So to do that, we are going to replace where there is concentration, we put the concentration. Where there is volume, we put the volume. So the volume was 750 ml. The concentration of cerium nitrate is 4 by 10 to the power negative 3 molar. So replacing that in the formula, punch that in the calculator, we're going to have 3 millimole. So this 3 millimole is resulting because the volume is in mils. So if the volume is in mils, the number of moles will also be in millimoles. So don't worry about the millimoles. It will cancel when we calculate the concentration of cerium. In this case here, we can use it, but mostly we are required to convert that to SI units, which is liters. But here we can just leave it and it will cancel when you calculate the concentrations. So that is the number of moles of cerium. But let's calculate the concentration, which we are going to use to find the QC. So the concentration of cerium will be the number of moles over the volume. Remember now here, the volume will be 750 mils plus 300 mils. Why? Because we want the concentration when these two now have been the concentration of cerium in that product there. So this now has been added to 300 mils. That's why we are using 750 plus 300 mils there. But the number of moles won't change. The number of moles of the reactant will be the number of moles in the product there. So 300 millimole divided by 1050 mils will have our concentration as, our concentration will be 2.8 by 10 to the power negative 3 molar. So the milli, as I said, they have cancelled there because we have the mils in the denominator and the mils in the numerator. So the m there will cancel. We are going to remain with mole per liter, which is just molar. So that is the concentration of cerium. So let's find the concentration of iodate. So the concentration of iodate, we are going to use the concentration of potassium iodate and the volume of potassium iodate to find the number of moles of iodate, and then from there we are going to use that number of moles to calculate the concentration in that product now, as we did for cerium. So to do that, the number of moles is given by concentration multiplied by volume. So the concentration of potassium iodate was 2.0 by 10 to the power negative 2 molar multiplied by 300 mils. Before it was added, we need to find the number of moles. So when you multiply these two, you are going to find 6 millimole of iodate. Now that 6 millimole, you use it now to calculate the concentration of iodate in a product of cerium iodate. So I have the number of moles, which is 6 millimole now, and the volume will be 300 mils plus 750 mils when it was added now. So it will be 6 millimole over 1050 mils. Then the m will cancel. We are going to remain with mole over liter. And then when you divide that, you are going to have 5.71 by 10 to the power negative 3 molar. So that is the concentration of iodate. So let's now calculate the QC and compare it to the KC. But before that, let's write the ionization equation for cerium iodate. So when cerium iodate decompose, it will form cerium as an ion raised to the power 3 and iodate as a negative ion. So to balance the equation, we are going to find that we are going to have a 3 in front of iodate there. So to calculate the QC, we simply replace the concentrations. We have already calculated the concentrations, so we simply replace in this formula, which is QC is equals to the concentration of cerium multiplied by the concentration of iodate raised to the stoichiometric coefficient, which is 3 there. So the concentration of cerium, we found that it was 2.86 by 10 to the power 3, and the concentration of iodate was 5.71 by 10 to the power negative 3 there, raised to the power 3. Why? Because it is the stoichiometric coefficient, we include it there. So our QC will be 5.32 by 10 to the power negative 10. So we compare our QC here with our KSP. So if we compare that, our KSP was given as 1.9 by 10 to the power negative 10, and we have found that ours is 5.32 to the power times 10 to the power negative 10. So this shows that our QC is greater than our KSP, meaning If the QC is greater than KSP, then the resulting solution will form a precipitate. So sodium iodate will form a precipitate as a result. Okay, so thank you very much for watching this video. Remember, don't forget to like, subscribe, and leave out your comment in the comment section below.